Well, hi everybody, and I haven't looked at all the people that are listening in, but I did recognize some names a few minutes ago, and I did. So hi to those of you who know me, and hi to those of you who don't. I was happy and pleased to get this little request from Serena, and so the title that I believe you gave me, Serena, is Grazing Impacts on Soil and Plant Productivity, but she also asked that I take a look at stocking rates, grazing capacity, or carrying capacity, however you want to do it too. So that's sort of where we're going to start out. But the first slide indicates, when it comes to grazing rotation, there's a million different things, from plan to system to strategic to mob grazing to everything else. And I did manage to find two places that use these terms, that being the Maya Grazing Group and Colorado State University. So they talk about continuous grazing, which I think everybody knows is just one geographic area, and you stock it according to how much it'll carry you through the season. And then slow rotational grazing, which is rotating every 2 to 10 weeks. It could be longer, but that's the rough zone. Then planned rotational grazing at 3 to 10 days between movements. And then management intensive grazing, which is a fairly new coin that's been termed by people like Mr. Garish and a few others, and that's a 1 to 4 day turnaround. Then you've got mob grazing, which employs from 75 to 300 plus animal units, or 1,000-pound animals per acre. And then a modification of that, adaptive high stock density grazing, and that adjusts for conditions and or nutritional needs. And all of them probably are intending to do that in one form or another in terms of how you plan it. The key thing for me is to remind people that there isn't a best scenario. Okay, so what is best? And I have a very simple solution to that. The one that makes sense to you and your operation. And that includes the things that you like to do and hate doing. So in the fundamental sense, however, you have to consider your landscape, your forage resources, your objectives, finances, and the time that you or your family or your employees have to devote to rotating livestock. And what do you enjoy doing, which I think is pretty critical, because if you don't enjoy moving electric fences or herding cattle or distributing cattle, then you ought not to pick that one, because you're probably not going to be inclined to do that great of a job, because it's going to feel like it's a burden. And then you should be considering what your current scenario is and saying, well, what's lacking in that and what's working, because you can learn a lot from what you perceive as lacking in your current operation, and you can get a better understanding of what's working. And then the final bullet is just to remember water. It doesn't matter where you are in this world, we all need to drink water, and that includes our livestock. So when you are designing a system, you're going to have to remember where your water sources are, decide whether you have to do any water development, whether you're going to need laneways or alleyways or whatever to get to and from, to get the livestock to and from your grazing paddock or field. And then the other part that I put in is, you know, it goes to any system, but particularly in continuous or the slow rotation systems. Can you use water to distribute your livestock and have the impacts of water and water's proximity do the same thing as electric fences or permanent fences can do? And I guess I should have said this beforehand, but if anybody wants to jump in, add in, or ask me a question throughout this, I'll trust Serena to moderate that, but I don't mind at all being interrupted. In fact, it's quite stimulating, so it'll help my narrative immensely if you do. So getting back to distributing livestock, there's a fair number of scenarios in the South Okanagan, the Central Okanagan, and I dare say in the Caribou, where water, whether it's done deliberately or accidentally because of a lack of water or an abundance of water, winds up helping you distribute your livestock throughout an environment. Some people go to great ends, like some of the operations in the South Okanagan will actually move animals away from a water source, block that water source off, and take them to another water source in a geographic area. And it works quite well. Now I can't move. What's going on? So then I wanted to do a little reminder. I think Mike Witt and I think Bart also did some conversations about what happens in terms of the nutrition in the environment. So these are just two general pieces to look at crude protein in the plant cycle. So the dotted line in green is a grass plant, and the shrubs are red and the forbs are yellow. And basically you can see that from the time plants start at the earlier vegetative state and move through the reproductive state, crude protein is dropping in these plants at very different rates, but they're all dropping. So you can see that shrubs retain a higher portion of crude protein than grasses do later in the season. And it's the same pattern for energy, except that the coin's tossed. Grasses provide more energy later in the season than shrubs do, and forbs get to live their life in the middle. And I just do that as a way of reminding us that that's one of the things that we need to consider. One of the things that that if we want to raise calves, have cows milk well, have yearlings or any other animals survive and grow the way we want it to, we need to be considering what they have available going into their mouths. One of the things that we do know, and I'll just flip to this slide as I talk to it, is that through the course of any grazing season, it can depend quite a lot on where your animals are. So if your animals are on a very diverse rangeland pasture system where there's a wide variety of grass types, forbs and shrub types, and they're in a slow or a continuous grazing system, then they can probably wander around and select the nutrition that they need pretty adequately. But if they're on an intensively managed pasture that has only 1 to 4 species in it, then they might be constrained by the amount of selection they have to make available, and they'll select early growth if they want more nutrition or a higher level of protein and energy. And as the plants get older, then what you saw in the graph will start to happen, and that's with those fewer options.
Great. We do have one question,
yes?
Quick clarification for those following along of if you could clarify what you mean by what is a forb?
Oh, a forb? Well, that's like an alfalfa plant or a vetch or anything that's a broadleaf. I guess I could glibly say they have flowers instead of seed heads as well, if that makes sense to people. So this is a little depiction of forage volume growth above ground. And so the first one that we can see are cool season grasses, which are predominantly what we have in British Columbia. And you can see that they initiate growth fairly early in the spring, and their productivity jumps and they grow quite vigorously in that early spring. And then as summer or the heat of summer pops along, their growth tapers off and goes into a bit of a slump. And then moisture and nutrition willing, as you get into the fall, or in this depiction autumn, then they can recover and grow a little bit more quickly and provide more forage. And you can see that legumes follow a similar trend. However, they don't beep up quite as high as grasses do early in the spring in terms of the volume that they put out, but they maintain it more consistently throughout that warmer summer and into the fall. In warm season grasses that we have a few of, but not very many, tend to do their best growth in the heat of the summer, hence the name warm season. And they tend to, as part of that, they tend to be, well, I don't think they tend to be, they are more efficient users of water. So I'll take my breath and look at grazing capacity. So grazing capacity in its general sense is matching forage volume to livestock numbers. And the time and duration that you're going to graze those livestock. So some of the things that you need to consider, and I'm going to give you the considerations and then some tools that you can use to calculate this. But some of the considerations are what your animal intake is. So if you've got a lactating cow and it's going to be able to consume 2.5 or 3% of its dry matter intake of its body weight, then you need to know that. And then if you're going to be on that pasture for 1 day or 100 days, then you need to know that. And then you know what volume your animal intake is going to be. Then of course you can know that, but you need to have the volume on the ground or in your fields. So you need to know the volume of forage that's available and when it's going to be available. And when is particularly important, particularly in the more intensively managed or grazed system, because if you're early in the season, there may be less forage available in your paddock because it's just initiating growth and it hasn't accumulated volume. And then in that summer month, if it's a cool season, it's going to be growing more slowly. So unless you've accumulated volume that you haven't gotten to, then you're going to want to make some adjustments or be prepared to make some adjustments when that happens. The other part of when is if you don't have a nice flat plain that doesn't have very much elevation gain, then sometimes you're going to have forage that's available early in the season because it's at a low elevation. And in BC, it might even be a south or a southwest facing slope. So it's going to grow a little earlier and a little faster in the season and probably shut down a little earlier in the season as well. And as you go up in elevation, you can see that same phenomenon happening so long as you have plants there that are grazable. So that's part of the when that you're going to take into account if you're moving through elevation. If you're not, then it's just more following the season of growth patterns that forage puts up. You need to consider your pasture and livestock objectives, and by that I mean if you know that you're going to be pasturing livestock that you want high rates of gain or lactating, then you know that you're going to need to provide them with some nutritious forage, and their intake is likely going to be higher from a percentage perspective. And you need to have a sense of whether or not your pasture is a nice, highly producing pasture and it doesn't have a lot of things that when you look at it are wrong with it, or whether you've got a pasture that is perhaps has some open spaces in it, is lagging in the production that you think it could or should be achieving, or worse, is being invaded by plants that your livestock aren't willing to consume or aren't desirable in your setting. And then you need to sort of look at how much of that available above ground forage is going to be a safe target to use. Now, most times it's the 50% rule. That's the rule of thumb, and you can use that calculation, and that's fine. But if you have other objectives that would ask you to reduce that level of removal because you want to rejuvenate a pasture and potentially use it a little less to try and expedite that rejuvenation, then you give that consideration. And you might use a higher percentage removal rate if you were, for example, in an irrigated pasture setting. And so you have domestic forages, whether it's brome grass, orchard grass, whatever, in a combination with a few other grasses and maybe some legumes. And you may be looking at that calculation through the course of the year, and instead of calculating the available volume of forage, say you're in an environment where you can grow 8,000 pounds or four imperial tons of dry matter per acre, then you probably could do your stocking rate calculation at 70% of that if you're using a rotational system that's fairly effective for that environment. So calculation, and I call the calculation of carrying capacity the starting point, because after you've sort of got a sense of how many animals for what length of time and how you're going to manage those animals in your head, then you can start with that, and then you just need to be a very candid and honest observer for yourself, so that you just don't rely on the calculation that says I can turn 100 cows out here for 100 days, for example, on 100 acres. You want to monitor that with whatever monitoring you want to do, but mainly you want to just be a good observer of both your animal performance and your stands performance. So but the Beef Cattle Research Council has just if you find that link, you can go to it. It has a carrying capacity calculator. It uses a version of the methods that I've talked about. So if you want to you can calculate a carrying capacity in method 1 based on available provincial forage production guides. So if you happen to be, Dwayne's neighbor, you could go to the Alberta Forage Manual and or some of their data and get a pretty close estimate of how many pounds of dry matter per acre you could expect to produce in that particular soil type with those particular species. Or you could use another method in which you've done some clipping or some harvesting and you've determined through that type of a process your volume, and then you can go through that. So that's basically what this does. I'm not going to take any further than that. You can use method 1, method 2. It has an ISO calculator guideline. And I think in general, if you want some help, that can be a pretty easy site to go to. There are a number of other ones that are out on that you can Google and pop up, but this one's pretty nice and it's pretty relevant, particularly to Western Canada.
Yeah, Greg, we did have a question from Tim about how to figure out how much forage you have per acre. I know Tim's in the Prince George area. Would you be able to give like a quick, if you were to go out to do some clippings, a quick overview of how that would work?
Yeah, so Tim, let's do the simple one. Let's say you're going to look at your total forage volume and allocate back from there. So at some point in time, you're going to wait till the grass plants are, close to where you would normally harvest them. They're just at early seed set. And then you could just go out and clip them and take them in, and you could do an air if you don't have access. And it's pretty tough to have access to something that's sophisticated to dry it unless you happen to be near a research station. But you could air dry it and just weigh that out. And so what you would want to do is clip several areas in your field. You want to sort of go out about it so you don't just pick the least productive or the most productive site, but you want to get a bit of a representative sample of it. So you might take a dozen or 2 dozen samples, and then you could weigh those samples, and you'd want to have a consistent size of area that you would do. So maybe you'd take, a meter squared or half a meter squared and harvest that, and then extrapolate the average of all those clips that you did up into what it would be in kilograms per hectare or pounds per acre. And that's why one of the reasons why I indicated that you can also look to places like the Alberta Forage Manual or other places around and see basically what other people have had by way of production in those sites. But if you have a site that's unique and nobody's done work with that type of a scenario, then you may be faced with doing that type of a bit of work, I guess, to get to that first bit of estimates of what you can do. There are some sticks and tools out there, but they rely pretty heavily on being used in stands that are, fairly consistent, irrigated or hot or under high moisture, so that you can measure a volume of grass on a stick and extrapolate how many, some of them will extrapolate by 200 pounds per inch and things like that across the acreage. But if you've got a field that has sort of a robust change in vegetation type and stuff, you're probably not going to be very successful using that or one of those floating disc systems. So what we're really, hopefully that at least answered the question and didn't scare you away too much, Tim. So what you're looking at is getting some estimate of your total forage, and I just use pounds per acre because that's the way my brain was trained to think all those years ago, although there's not much difference between pounds per acre and kilograms per hectare, times the level of produce, so use, so you're going to remove 50% of it. Remember that you're really multiplying by 0.5, so either divide by 100 or just convert it to a decimal or a fraction as you see fit. and then you're going to divide it by the animal intake. I did it from a daily perspective, and so that would give you the number of animal days that you could put per acre. And so you can do that if you're a range person or you like the animal unit perspective, then you standardize around that 1,000-pound cow with calf and that intake. And then if you have one that's 1,300 pounds, you're going to increase it by the fractions that, and there's lots of tables in different manuals, including the Alberta Forage manual, that'll help you do that calculation. Or you can convert those animal units down into sheep or whatever. And then the other piece that you can do fairly readily is just take a look at what your current stocking rates or your historic stocking rates have been, and view those against your objectives. And by that, I mean, if your objective is to improve the productivity or the plant health of your environment, or your objectives is to increase your performance of your livestock. But your stocking rate starting point would be somewhere in that vein. And so if you looked at your historic stocking rates and you've been throwing 150 head out onto a pasture in the, quite regularly and historically for say 30 days, and you look at that pasture and you say, well, it's depleting. I don't know what I'm going to have to do with it, and I don't have the forage volume and the rates of gains that I'd like to have. Then you're obviously going to be wanting to start at a lower stocking rate and use your management system to potentially work back up to a higher rate. Now I will go to this one. If you have range type productivity information, I did manage to find this, so I'll quickly go to that. Hopefully it's still there. I always get nervous when I go to the provincial government's websites, having worked for them for the better part of four decades, or almost 4 decades. I know that they can be a bit hard to trip through. So in this site, this is in the section of range ecology. Interesting enough, if you want to see what those productivity levels might look like, and you're in the caribou, for example, and you look outside and you say, oh, I've got Douglas fir bunch grass, then you can click on the Douglas fir bunch grass, and I'll just scroll through this, and hopefully nobody's eyes roll over in the back of their head or get too discouraged by this, but they describe the site and they tell you the basic location, and they have their Beck correlation information there if you want to look at it further. And they tell you about the soils, and they tell you about the mix of species in the plant's potential natural community. And it gives you a productivity of 400 kilograms per hectare in this example. And it'll talk about some range considerations. The nicer part about this is that it'll show some pictures like this, and it'll say this is a late Cyril blue bunch grass, late Cyril blue bunch wheatgrass, rough fescue, and pine grass sage, and it'll give you the productivity of that. And I'll just whip down and show you another one. This will say this is a mid Cyril, and it'll say that the productivity is 200 kilograms. So you can sort of use this information if we're talking about a range setting. You can go and search through that and get your starting point from this information. And it doesn't matter if it's private land or crown land in those sites, it is what it is. They'll perform fairly similarly. They'll give you those same starting points. The one thing that I'm not sure if it's consistent all the way through all their sites is that in most instances, when they give the productivity information, say the 300 kilograms per hectare on that site, they're not including contributions from shrub species. And some people are in ranges where there's a fair amount of dry matter contribution available and used by their cows from the shrubs. So that's just something that when you do the calculation and you say, well, gee, I'm getting a lot more use and I'm not exceeding my use levels and everything's vigorous, it's possible that it's coming from shrubs or forbs that weren't available when the measuring was taking place. And some forbs that grow, they're very short-lived in their cycle. They're not like the alfalfas, et cetera, that we're used to seeing in our private pastures, or our domestic pastures, I should say. And they may only initiate growth, go through their peak, and fall off in a matter of 30 or 40 days. So through the course of a growing season, you could have 3 or 4 different forbs that might be growing at these different times. And if the clipping or the observations were made when those forbs were either hadn't initiated growth or had already finished growing and had already fallen to the ground, they may not be included either. But those are just refinements on the process that you can think of as you're going along. And so that concludes, so I'll just pause for a bit, Serene, and see if there's any other questions relative to carrying capacity, etc., before I get into this piece that's going to talk more about the above ground and below ground linkages.
Yeah, thank you, Greg. We have a question here from Brian, which is, are the measurements based on like the entire season's growth?
In the example that I gave to Tim, yes. However, if you want to do it in stages because you think you're going to graze a certain area, you know, say May and June, and then leave it alone, then you may want to make your clip, you know, at the end of that time frame, and that'll give you an idea of what your potential yield is from through May and into say mid-June. But in most instances, the best thing to do is to look at what your total volume is for the season, and use that as your starting point. Even, you know, and so if you're converting an existing alfalfa grass stand and you're going to graze it, and you know that you've been harvesting, you know, as I did in the earlier example, 4 tons of hay per acre, then you can use that as your starting point. And then as we flow through some of these grass growth cycles, and you start to consider how you're going to manage that either by rotation or leaving your animals on it, you can start to refine how much your idea of how much of that available dry matter forage is going to be available for you to grow, you know, considering how much you need to leave and the rest periods, and how much volume is going to be attributable to those rest periods, and just work through that. So that's a bit of a disjointed answer, I know, but essentially I think the easiest way would be, yes, do the full season and then start refining after that. But just recognize that if you are grazing really early in the year, then you're not going to have all that growth available to you at that time. So it means you might not get the full time frame that you may be able to calculate in terms of animal unit days, if you like.
Great, thank you. And we did have one other question from Karen, which was, do you think that we could grow warm season grasses in the central interior? And if so, which ones would you recommend?
Well, I'll be honest and say that that's a little over my head in terms of being able to answer it off the top. There are warm season plants, obviously, that we grow domestically, whether it's the sorghums or whatever people are trying. But in general, there aren't very many warm season grasses in our native environment, and there's not very many that are marketed in the seed market as well. And perhaps the main reason for that is that if I understand some of the work that's been done at a slightly lower latitude, but similar sort of cool environment in other areas like North Dakota and places like that, the difference between warm season and cool season grasses in terms of when they're going to go to head, which means when they're going to seed out, is plus or minus a week. And that would indicate to me that there's not a lot of space in our warm season zone, if you like, that warm season plants would give you a decided advantage, because they'd be growing and the cool seasons wouldn't be growing at all for a sustained length of time to gain some volume. And I wish I had a little bit better grasp for you on the names and the varieties. I don't think there's any harm in having a warm season plant there, and it could well diversify your stand and provide you with another option. But I don't know enough about the individual species to answer the question completely. Sorry.
Oh, no, that's a great answer, Greg. Thank you. And that's The Forage Council always promotes very small test plots.
Well, sometimes a very small is very small, all right. And I must confess, it's been, I don't know, Mike can correct me, but I think it's been at least 25 years since, as an employee of the Ministry of Agriculture, we had funding to do any species and variety and new species trials, though we did try and do that quite immensely through the 80s, and then attitudes and budgets changed. And so I'm not as conversant in those topics as I once was, because I don't live and breathe them on a regular basis. So the main part of the conversation is to look at, and I better speed up a little bit, Serena, the grass cycle and growth cycle and how that relates to the root environment. So I'm going to just take you through the basics of the grass cycle and some of the features of it. So you come out of the winter, you have dormant bud initiation in the spring for grasses. It's at the temperatures 4.4 to 4.5, I just say plus or minus 3 to 5 degrees Celsius. Leaves grow, and then you get a summer slowdown, and you also get, through that summer period, you're going to have the onset of seed production, and then you get regrowth and bud formation and carbohydrate storage for overwintering tillers. In general, the carbohydrate reserve follows that same logic. You start over here in the spring, you're respiring. Well, this isn't the spring, this is late winter. This is winter. You're respiring through the winter, and then you initiate some growth. And this to me, this little curve is a little bit out of line. I'm not sure how that happened, but it did. And so as you start to initiate growth in the 2-leaf stage, there's still a slight draw on the measured carbohydrates. And then as you get at the sort of standard average is 3.5 leaf stage, then you've got grass plants that have got enough physical area to be making vigorous growth and net contributions to the carbohydrate status. And that progresses through the year in the manner that you see on the curve. Then the thing is plants grow from something, and then we'll just use the term growing points in this example. And where these growing parts are during the season can be particularly important to pay attention to particularly when you're grazing, or even when you're harvesting with a piece of metal. So that's the place where cells divide and elongate. And in the vegetative phase, they're located near the ground, and then they're raised as the stems elongate through the transition stage and into the reproductive stage. And in this example, we're showing a grass tiller that its growing point is going to move through and provide a seed head. Now you're going to see vegetative stage, transition stage, reproductive stage. You're going to see in literature early, mid, late. You're going to see all sorts of terms, but basically they all break down into those 3 basic groups, which is early, which is sometimes the early on, is up to the 3 to 4 leaf stage. Then you get into the more rapid growth stage at the stage 2 or the transition stage, and then you get into that physiological slowdown on the tillers that are going to produce seed. They don't no longer produce leaves, but they're now producing seed. So this is just the same thing, just with the picture of a real living plant, showing you where in the vegetative state the growing parts are. Of course, they're the little red dots, and I'm sure you all figured that out before I did. Forbs also have growing points, and just about every year forbs grow from buds located in the root zone. You can look at all the terms that are there to describe that, but essentially the root zone, and the pretty picture is, it says an Arctic blueprint. And reproduction growth habits are similar to plants in that they have growing points. The difference is that most of the growing points are elevated rather than at the ground. And so this is an overexpression of that, in my opinion, but the growing points elevate, and they move up above the ground. And so where in a grass plant, the growth was initiated below the leaves. So when they're in the transition stage or early stage, you're not going to run the risk of clipping the growing point off. With most forbs, they're elevated, so when some grazing occurs, some of those growing points are going to be removed, and then there'll be no growth from that zone of the plant. This is just another representation of a grass plant. Show on the left, and it's a bit fuzzy because the image wasn't as clear as it could have been. So it just shows that you have roots and tillers, and we have a tiller or shoot coming up here, and this central one is another tiller and shoot, and that's showing it at the stage where it's got a seed head, it's got internodes, an internode space, and nodes all along it. And then in this instance, this particular representation is rhizomatous, so you have a new tiller initiating from the rhizomes. And this shows that the grass tiller and how it grows here and its components. And so that is down here at the base of the plant near the soil. And this is a little bit easier to see. So you have your leaf bade, you have your sheath, and then you have your apical meristem. Plays a particularly important role in that apical meristem produces some auxins, and those auxins in turn reduce the ability of these axillary buds, one of which is shown there, to grow and become an independent tiller. And we'll talk more about those a little later. I think most of us are pretty familiar that if you remove leaves, you reduce photosynthesis and subsequent growth of the carbohydrate production, and the continued removal of a leaf area can drain the carbohydrate reserves. When it comes to grazing, we're looking at this you're looking at this from the context of where are those tillers when your livestock are grazing. So if you're in a vegetative state like this example is, then you can remove, your cow can remove that, and then as long as they're not coming back right away, this plant will then recover. So you rotate out of that pasture at this point, for example, and it'll regrow, and it'll continue to grow from these growing points on the ground. And the only thing that would improve this picture is if instead of having little boat-shaped leaves, they were all chewed off like they are there, because you'll see that chew mark when you look at the leaves. And when you have reproductive tillers, and not all tillers are reproductive in a grass plant, most tillers live a plus or minus 2 years, depending on their circumstances. So as they elevate, then grazing can remove the tillers. When those tillers or those growing points, removed, then they're going to start down here from a basal bud or an axillary growing point that's going to expand, and then you'll have growth from that lower area. It's going to be a little bit more slower process, obviously, than the earlier one, because you're going to have to, those tillers and those growing points are going to have to start almost from scratch. So what does this mean relative to roots? Well, if you have a grass plant that's healthy, it needs to have a healthy root system. And so as this goes through, and there's just a little graphic of some roots that were in a washout that somebody took a picture of. So they accumulate, grass plants will accumulate mass above and below ground. Their healthy and big root system is essential for extracting soil moisture and nutrients. And if you don't have that healthy root system, then you're definitely not going to have a productive stand, or as productive stand. This picture you've seen a dozen times, I'm sure, and everybody's seen this. It's probably the most used picture in the world in terms of agriculture, but this is a study that depicts the different grazing regimes that Kreider did in 1955. And obviously the more frequently and closer he clipped the grass plants, the less photosynthetic area he had, and the less ability those grass plants had to maintain this nice, healthy, vigorous root system that you have over here. Perhaps some of the more important interpretations of this are depicted in this slide. And in this slide, you can see that forage removal tends to result in the stoppage of root growth when you exceed 50%. So that can give you a little bit of a sense of where the, you know, the graze 50, leave 50 rule comes from. It's not an absolute. It's basically a generality. So it's a very good starting point, but it reminds us that if you remove a lot of photosynthetic area, then you're going to both reduce that photosynthetic area isn't going to provide you forage above ground, but it's also not going to be able to provide the photosynthetic activity quickly enough to maintain root growth. And if that is sustained over a period of time, you could end up with root growth restrictions. The other thing to say about grass plants and the roots is that the roots, they're not like trees. Their roots don't live forever, or try to live forever, I guess would be a better way to phrase it. Typically, a grass will slough or plus or minus 40% of the root mass that's below ground will be replaced annually. So that provides some organic matter into the soil that in an inactive form that contributes to nutrition and also to soil health. Now, I'm just going to show this picture. This is just a nice picture to show different root systems. But I want to pause here and just indicate that it's not root health and these activities and the need to have vigorous above ground growth to maintain and support vigorous below ground growth. They're intricately linked. And that's part of keeping integrity, maintaining the integrity of the root system and the soil structure system. And part of that is you've heard terms through the years. When I first heard about plant soil structure and roots and root zones, etc., they talked about the tilth of the soil, which was a measure of the aggregation of soil particles and the ability that they have to stay together in these aggregates, and then that which would expedite the movement of the interchange of nutrients and through microbial activity and other systems, as well as improve the infiltration of water and the capture of water in those organic zones. This is just a nice prairie grassland system. I think it might be a depiction from the Great Plains, but I'm not dead sure. Dwayne can verify that if you would like. The zone where most of the activity happens is around the roots is called the rhizosphere. And of late, there's been a lot more work being done on trying to characterize and understand the mechanisms of all the things that are going on within this rhizosphere and within that soil environment. So I just show you these pictures. I'm certainly not an expert in this by any stretch of the imagination, but you can see that this is a depiction of the root, and it shows the tip of the root, and this area that's in these dotted lines is basically the area of interest. So you have root hairs, and you have this rhizosphere that's over here, and it shows the interlinkages between fungi, between bacteria, protozoa, microbial activity, rhizomes. The whole ball of wax is active in this area. And this is a somewhat of a dependent relationship. If those roots are not actively growing, either releasing some materials like these cells at the border that get rubbed off as the root progresses through because they're there to help the root pressures through soil, then some of them invariably are providing some slippage and they slide away from the living tissue itself. That provides energy to organic matter to the soil environment for the microbes. And they also have exudates. You can see the little bacterial nodule alluded to as well. And this is a closer depiction of a rhizosphere. I'm certainly not going to talk to it, but you have the vascular tissue. And you can see they've defined two zones. There's the endorhizosphere, or that part that seems to have a fundamental physical connection between the critters in this area and the tissue of the root, and then the ectorhizosphere, which is external to that, but it plays just as integral a role. I'll take a pause and see if somebody wants to ask me any questions about that, Serena, and then I'm going to give you two examples, or examples that explain how you can use these features.
Yes, thanks, Greg. We did have one question come in from Tim. How long would you expect to be able to graze into the fall? So once the grass is dormant going into winter, how long would it be safe to be grazing that grass, and in terms of effects on future root health?
Okay, so how about if I just defer that, because we're going to talk a fair amount about things like that in these next two pieces, if you don't mind, Tim, and then re-ask the question if it hasn't become clear in that.
Perfect.
So one of the people that Helen pointed out to me a year and a bit ago when I was in Williams Lake at the soil course that was there was this gentleman, Dr. Lee Mansk from North Dakota State University. And he's a prolific person when I looked him up, and he's done a lot of work with respect to grazing systems, with respect to characterizing and summarizing synthesizing, and actually doing work in the rhizosphere area, and watching what changes in the rhizosphere mean to changes above ground and vice versa, as well as he has a very good synthesis paper on growing points and their life sequences and the pros and cons. So the best way I thought to describe some of his work was to go through something that's relatively unique, I think, and that's the twice over rotational system, and that Lee has used in a couple of instances, and we'll get to that example a little bit later. But the twice over rotational system, it is, Mike, just what it seems. You're going to graze that same geographic area in a range setting, by the way. And this is a Northern Plains example that he's going to use, but that's the setting that this work was done in. You're going to graze it twice in the season, which is a pretty aggressive sounding approach. So part of the principles that underpin the success of this system and the logic of the system is that you begin grazing after the 3.5 leaf stage. You coordinate grazing rotation timing dates with grass growth stages, and that grazing between the 3.5 stage and the flowering stage for no less than 7 and no more than 17 days, and in that time frame removing 25 to 30% of the leaf area is one of the key principles. And then you don't graze spring and summer pastures in the fall, which gets to the question that was just asked. And the reason for that is it reduces the carryover secondary and new tiller survival, because the vast majority of cool season plants will start to move carbohydrates and energy reserves down out of their leaf area in preparation for having enough energy to do their slow respiration challenge to overwinter, as well as put in enough energy, hopefully, to support and maintain the growing points that are going to be available for production in the next year. So in this instance, on a range situation, he's pretty firm. This example would not have you graze after October 15th at any level. We'll talk of variations of those themes in a little bit. So this rotational system uses 3 or 6 pastures, and then from early June to mid-October, which is the October 15th piece, each pasture was grazed twice. The first graze was in that period I just mentioned, and that period lasts between the 3-leaf stage and the flowering stage about 45 days. So if you had 3 pastures, if you just took 17 times 3, it'd be pretty close to 45. And so that's the magic of the 3 or 6 pastures. You could cut it in half and not go below his 7 days. And in that stage, it stimulates tillering from the axillary bloods and provides enhanced activity of the rhizosphere organisms, and that results in increased production and extended nutrient quality. Well, you have improved nutrient quality with the regrowth right away. And the second graze is going to happen after flowering, and that's going to happen until mid-November or October, sorry. And you're going to graze that if you use the 17 days, you're going to graze that for twice as long in that pasture. So you're going to graze it for 34 days. And all of this is his calculation for how many animals, et cetera, to achieve this is that he takes his carrying capacity calculation, his stocking level across the full season, and applies that to these different stages. So if he's got a carrying capacity of, say, a half a cow per acre, or whatever it might be in your environment, then that's what he uses in terms of the volumes of animals he puts into this pasture rotation system. So then further, when he did this in conjunction with domestic pastures, for example, used crested wheatgrass in the spring, and either used a winter annual, or I put Altai wild rye, but I didn't need to put a variety in there. It could just be wild rye that you use in the late fall, i.e. after October 15th. Then he's been able to provide 6.5 months of grazing with the nutritional forage, all being at or slightly below the requirements of a lactating cow through that full 6.5 months. So he did this on a 805 hectare ranch. It's interesting, his paper was published worldwide as part of a booklet, so he uses hectares a fair amount in kilograms per hectare because of it's more uniquely used around the world, I guess. Did this between 2006 and 2007, and indeed it worked. The note here is that with this process that he used, he had a 3-year lag until he could measure a substantial increase in rhizosphere weight. Okay, so that's the summary. So what happens when we go back here in this first graze? The idea is that you remove that 25 to 30%. That removes some of the tops of those grass plants off, and in some instances it may be late enough that it captures an elongating growing point that's going to provide a seed head. In other instances, it's just going to remove leaf area. Removal of that leaf area reduces the amount of oxygen that those plants that its apical meristem is producing, and that triggers the ability, that reduction, for different hormonal changes in the plant, and it stimulates some of those axillary buds to actually initiate growth and perhaps become a new tiller. And can stimulate more than one axillary bud, which is typically what happens if you let it go through its life cycle. That also triggers an enhanced photosynthetic activity within the plant itself. Grazing does that in general. When you graze the plant and it has the time and the nutrients and water, moisture to grow, it will enhance the rate of photosynthetic activity. So it also grows more vegetative area, which is higher nutrition, but it also provides more energy into the root system. And I don't want to get too much further into that, but that energy into the root system allows that root system to put more energy into the soil, or more sources of energy and food into the soil for the fungi and the bacteria and the protozoas and all the microbial activity that's down there. And so that activity expands and increases, provides more nutrients again to the plants. The roots are expanding and growing quite vigorously at that stage. And it's that creates the increase in rhizosphere volume. And as the rhizosphere volume increases, there's more availability of nutrients, particularly nitrogen, that can be to that plant to grow. And in the study that he did when they monitored it, I believe it was he gained 140%. Yeah, his volume of productivity was 140% of what it was before he initiated the rotation. So
Greg, I'm going to jump in there because we did have a comment from Brian that said
I'm over time.
Oh, it's all good. They had snow cover from mid-October on, but looking at your slide, it's like anytime after flowering to mid-October, correct? So that you could get started, even if you're going to get some snow cover in mid-October.
Yeah, I think that you're going to you know, I'm using these dates because most plants' growth stages are daylight sensitive, but weather and other factors, snow, freeze, freezing activity can change that on any given year and in any given environment. So it's, you know, everything I say you don't take as an absolute. It's just what, you know, I'm just in this instance reporting out where his time cutoffs were generally in that area. So if you're looking at that sort of a situation, my understanding and what I've observed in the pastures that I've managed is that in that mid-October to November stage, if you're down in my country, it would get into November. If you're further north, it would be the early part of October. Then those plants are starting to set up, for lack of a better way of explaining it, to go through the winter. At that point, you're going to want to ensure that you're not trampling or grazing a lot of that volume, so that you're removing the ability for that plant to have healthy growing points the next spring. Some of those tillers that are there at that time, they're going to be what are called late tillers, and those tillers are actually going to initiate growth next spring if you haven't removed the physical ability for them to do it by removing the leaf area. What happens in that instance is when the temperatures warm up, they go from being brown or a pale yellow like mine are in my field right now, and they start to pump energy into there and develop more chlorophyll, and then they start to photosynthesize from that leaf, and then we'll attach that or some of the growing points that are sitting there idling or respiring through the winter, and they're going to initiate growth and in that instance they're going to use some of the energy that they've stored to put out that green leaf material and start photosynthesizing. So, and then if you're looking at that from well, I've got a whole bunch of grass sitting there, Greg, and I don't want to stay off of it, I can't, then my suggestion is that if you can go in there and not have them on an area trampling it too much, then go ahead and graze it, but leave yourself, I don't know, use a rule of thumb of plus or minus 4 inches, well, plus 4 inches, so that you have some material there to provide some buffer for the temperatures in terms of insulation, to continue to have ground cover, and to provide some opportunity for those late tillers to still exist to grow from in the spring. Now, if you can't do that, then you make that choice and look to address it in the future. So there's nothing, you know, unless you do it harsh enough that you're putting yourself into a complete desert situation where you've got no plants, then you just manage it so that you can recover by using the same principles that we went through in terms of not putting stressors on the plants at critical periods. And to help you think through that, I'm going to quickly go through the grazing response if you'll give me time, Serena.
Yeah, absolutely.
Okay, so I apologize. Maybe I should have timed myself better. Yesterday I went through this in 45 minutes. Today, not so much. Obviously, I talk more when I'm talking to others. So in this instance, the Grazing Response Index emphasizes the importance of plant vinegar for all the attributes we've discussed earlier. And it's there to help you assess the impacts of the current year's grazing. And from that, you can inform next year's grazing. You apply it to individual sites or pastures. And I put a bullet at the bottom. It's not a site evaluation or monitoring tour. This is a way of looking at your pasture and what you've done in that year to give you an insight as to what you might do in the future. So the Grazing Response, I get credit where credit's due. We adapted this version from one in Colorado that was developed by Floyd Reed, Roy Roth, and Dave Bradford. Floyd Reed and Dave Bradford worked for the Forest Service, and Roy Roth is with Colorado State, or was at that time, if he isn't still. So the frequency, it's going to look at frequency of grazing, the intensity of grazing, and the opportunity time. And you'll see this FIO acronym around a lot these days. And it means the same thing in every example, though it may not be used like it is here. Frequency is the number of times plants are defoliated in the growing season. And by that, we mean like plant A, how many times did somebody come and graze that plant? Intensity refers to the amount of leaf area, and we change this from removed so that people don't mistake it for percent growth, for all the things about consumption of grazing that has its own way of indexing in terms of level of use. So we are looking at it from the critical feature in there, and that's how much leaf material is remaining after grazing. And opportunity relates to the amount of time plants have to grow or regrow. And it's also considered the most important of the three. So when we see a little chart that I'll show you quickly at the end, you'll note that it gets a little bit more emphasis than the other two. So this is the chart. And you can see that basically frequency is based on the premise that it takes 7 to 10 days normally for plants to initiate growth to where they get to a stage where they're able to grow and put with enough photosynthetic energy to carry on. So if you've grazed it for less than 7 days, and then the chance of defoliating that same tiller or leaf plant or part of the plant's second time, so that you've hit it and then hit it again, so you've stressed it and then re-stressed it in short order, then that's the number of defoliations of 1 is considered to be pretty good, and it gives a positive value. If you have it for 14 days, it's sort of neutral. You've been able to remove it twice, and 3 or more, you get a -1. The percent leaf material remaining is a factor of some of the root indices that you have, and also the stresses it can be on the plant itself if it doesn't have enough photosynthetic area. So it has its point value. And then it's a bit more of a harder one to distinguish, but you've got the opportunity to grow or regrow. And so you have full season most of the season, some chance, little chance, or no chance. And you roll it up and you add it up and you get a score. And the thing to look at is that you don't worry about whether you're all positive or all negative. You just use that as an observation guide. And if you end up with a GRI total score that's positive, then you can be pretty comfortable that you're maintaining some decent plant vigor. And that's what this is really guiding us to look at, is, are these plants vigorous? And if it's in the negative, you can look at that. And if you can say, well, that was an anomaly because this was a really dry year. So this opportunity to grow and regrow is real opportunity. If you've got a drought year, and so your effective growing season is shortened, you take that into account in this scoring. It's not an average year. And then if you had a really wet year, you may have the opposite. So I've just got some recaps, and Serena, and then we'll go for questions if you'll allow that time. So the recap is that most tillers typically live 2 years, and typically in the second year it sets seeds. It's not a hard and fast rule, but in general, if you've watched a grass plant grow, whether it's in your pasture or whether it's in your hay field, you'll see that not all the tillers are setting seed. And when you remove the seed, the ones that have set seed, they regrow from the bottom, as do the other ones, but there you go. So it's critical to both above and below ground growth. We've gone through that. The other thing is that grass plants are a sort of, I call them an amalgam of tillers. They do share nutrients across that seam in terms of the root system and stuff, but it's on a limited basis is the best way I can frame it. One tiller isn't going to suck another tiller dry, essentially. It takes 7 to 10 days to produce a new self-supporting tiller. And you may have seen that when you've harvested a grass stand. It requires, all the plants require time and resource to grow. I'll reemphasize the critical period, and then the frequency of grazing. Transition stage grazing, just to recap what Leah's found, is that stimulate secondary tiller growth and potentially tillering from auxiliary buds. And that can increase your stand density, it can increase your volume, and we also discussed how it increases the activity in the rhizosphere and productivity. And so the other pieces are there, we've already gone through. Vigorous plants promote root growth, more aggregated soils, better microbial health and rhizosphere organisms, and well-functioning ecosystem processes. And with that, I'll say thanks.